Guys, in this class I shall be teaching you pure strategies under game theory. We shall take lots of examples. Guys, this is the example of prisoner's dilemma. Suppose there are two suspects and the police does not have any evidence against them. So what they do is they keep them in a separate room and tell them the following three things. If you think on your companion but your companion does not think on you, you will get 1 year and your companion will get 4 years in jail. If you both think on each other, you will each get 3 years in jail. If you both remain silent, both will get 2 years in jail. Now, the following thing is called a payoff matrix, and usually it is expressed in positive terms. So if you have a look at those three conditions, you will find that the maximum imprisonment is 4 years. Now, there are two strategies available to both these aspects, which we call players. Either they think or they remain silent. So first is think and think. So if they both think on each other, that is the second point. They were getting a jail of 3 years, whereas the maximum 4 years. So 1 and 1, that is years of freedom. What about if one guy thinks and other guys remains silent? That is first condition. So if the guy who is thinking will get only 1 year as sentence, and the other guy will get 4 years in jail. So in terms of freedom, the guy who thinks will get 3 years of freedom, whereas the other guy who doesn't think will get 0. Third condition is if they both remain silent. So if they both remain silent, they both will get 2 years in jail. Maximum jail being 4 years. So the years of freedom shall be 2 years each. So I shall now be teaching you how to solve a Nash equilibrium under prisoner's dilemma. Now guys, I shall teach you how to solve a Nash equilibrium. Now, how to play this game? Well guys, suppose suspect 1 thinks that the suspect 2 is gonna think. Though he doesn't know what the other guy is gonna do, but suppose suspect 1 assumes that suspect 2 is gonna think. Now suspect 1 has to decide whether he should think or he should remain silent. So if he thinks, he'll get 1 year of freedom. If he remains silent, he'll get a 0 year of freedom. So I think it makes sense for this guy to think. So I'm just underlining that. I repeat. If suspect 1 thinks that the suspect 2 is gonna think, suspect 1 has to decide whether he is gonna think or he's gonna remain silent. Now suppose if he looks at the options available, if he thinks, he'll get 1 year of freedom. If he remains silent, he'll get a 0 year of freedom. So it makes sense for him to think. Now, suppose now suspect 1 thinks that the suspect 2 is going to remain silent. Now again he has to decide whether he's going to think or he's going to remain silent. If he thinks, 3 years of freedom. If he remains silent, 2 years of freedom. Again it makes sense for him to think. Now we will play this game in reverse. Now suspect 2, suppose suspect 2 thinks that this suspect 1 is gonna think. Now suspect 2 has to decide whether he should be thinking or remaining silent. If he thinks, 1 year of freedom. If he remains silent, 0. So he's gonna think. Now again suspect 2 thinks that suspect 1 is going to remain silent. Now suspect 2 needs to decide whether he wants to think, that's 3, or whether he wants to remain silent, that is 2. So 3 does make sense to us. So I'm going to again revise or repeat that for you. Suppose suspect 1 thinks that suspect 2 is going to think. So suspect 1 has 2 options, think or silent. If he thinks, 1 year of freedom. If he remains silent, 0. So think. Suppose suspect 1 thinks that suspect 2 is going to remain silent. Suspect 1 has to choose either to think or to remain silent. If he thinks, 3. If he remains silent, 2. It makes sense to think. So you must have observed one thing here, that whether suspect 1 or rather suspect 2 is thinking or remaining silent, suspect 1 is going for thinking. This is called dominant strategy. Now same is going to be applicable with suspect 2. Suppose suspect 2 thinks that suspect 1 is going to think. So don't you think he has to decide whether to think or remain silent? Think, 1 year, silent, 0. So he's going to think. So now suppose suspect 2 thinks that suspect 1 is going to remain silent. He has to decide think or silent? Think. So again, suspect 2, irrespective of what the suspect 1 is doing, that is either thinking or remaining silent, suspect 2 is thinking. So again, this guy also has a dominant strategy. A dominant strategy is one that says irrespective of what the other guy is doing, for one particular player is sticking to one particular strategy. In this case, the strategies are either to think or to remain silent. Now, if you look, this think has two underlying things. So this is gonna be Nash Equilibrium, where you get the 2 points which are underlined, or all the options which get underlined is called Nash Equilibrium. Here you have only one underline, here you have only one underline, here you have none. So where you have both of the points underlined, that will be called as your Nash Equilibrium, or in other words, best possible point. Now I shall be teaching you a very famous game called Battle of the Sexes. Suppose there is a couple, a husband and a wife. They both want to go to a date on this coming weekend. The wife loves to go to ballet, and while the husband loves to go to boxing. Well, in this game, the main condition is that they should be together. So I repeat the rules of the game. Wife loves to go to ballet while husband loves to go to boxing, but the main condition is that they should be together. So now, in order to make a payoff matrix in such a game, see what I have done. Here player 1 is wife, player 2 is husband. You could interchange it as well. You could have taken husband here and wife here, no problems. So first and foremost thing is you should be able to build a payoff matrix on your own. So now suppose wife, that is player 1, has got two strategies up her sleeves, that is ballet and boxing. Whereas husband also has two strategies, ballet and boxing. That is, they need to decide whether they want to go to ballet or they want to go to boxing. Now suppose ballet and ballet. So if they both are going to ballet, don't you think wife would be more happy? So I have given her 2 points. Whereas husband will get 1 point because at least he is with his wife. Well, if wife goes to ballet, husband goes to boxing, they both get 0 because the main condition, that is they should be together, is violating. Now boxing, ballet, same thing. They're not together. What about boxing? Well, in that case, wife is gonna get 1 because she's with, her husband, and the husband is gonna get 2 because not only he's with his wife, also he gets to watch a boxing match. Let's play this game, Battle of the Sexes, pure strategy. Now suppose wife thinks that husband is gonna go for ballet. Wife thinks that husband is gonna go for ballet. Wife has to then decide ballet or boxing, ballet or boxing, ballet or boxing. Well, ballet. Now suppose wife thinks husband is gonna go for boxing. Wife has to decide ballet or boxing, ballet or boxing, ballet or boxing, boxing. Here, if you think, if you see it properly, there is no dominant strategy. Dominant strategy is one where rather one player is, sticking to one particular strategy irrespective of what the other guy is doing. Here, I'm afraid that is not happening. Now we will play this game from the point of view of husband. Now suppose husband thinks that the wife is going to go for ballet. Husband has to decide ballet or boxing, ballet or boxing, ballet or boxing. Well, ballet. Now suppose husband thinks that the wife is going to go for boxing. So husband has to decide ballet, boxing, well, boxing. Now don't you think, guys, we have got 2 points, ballet and boxing, where both the options are underlined. So in this case, my dear friends, we have got 2 Nash Equilibriums. Now guys, I've got this third game for you. The game is a very famous one called rock, paper and scissor. Let's first clear the rules. Rock defeats scissor because it can break it, scissor defeats paper because it can cut it, and paper defeats rock because it can cover it. In this game we have got 2 players. The winner is gonna get a $1 and the loser is also has to give a $1 away. So player 1 has 3 strategies, rock, paper, scissor, and player 2 also has 3 strategies, rock, paper and scissor. Let's start. Now suppose player 1 thinks that player 2 will play rock. So he has to decide rock, paper, scissor. Rock, paper, scissor. I think should be going for paper. Now suppose player 1 thinks that player 2 is gonna play paper. So player 1, rock, paper, scissor. I think scissor. So now suppose player 1 thinks that player 2 is gonna play scissor. So rock, paper, scissor. He's gonna go for rock. Reverse the game. Now player 2 thinks that player 1 is gonna play rock. He has to decide rock, paper, scissor, paper. Player 2 thinks that player 1 is gonna play paper. So player 2, rock, paper, scissor. So I think if you see, it's scissor. So player 2 thinks player 1 is gonna play scissor. What is player 2 gonna do? Rock, paper, scissor, rock. You will find in this particular game that there is no such box where both the points are underlined. So in this case we have no Nash Equilibrium, and I've got one more way to prove it why there is no Nash Equilibrium. Well guys, Nash Equilibrium is like a general equilibrium point which actually suggests the best possible outcome for both the players. Now don't you think in this case, if there is a tie, it cannot be considered as the best outcome for both, because the best outcome always has to be win. But now suppose if one wins and one loses, so the guy who has lost, that particular outcome will not be considered best for him. So that's why in such a game we can't have a Nash Equilibrium, because we can't have a point where both the guys, both the players are getting maximum advantage or maximum benefit. Guys, I now have one more game of pure strategy. Suppose there are two firms, firm A and firm B. Let it be a case of a duopoly. Now, they have two strategies. Either they can charge a low price for the products they are selling, or they can charge a higher prices. We have an imaginary values over here. Suppose firm A and firm B both charges low prices, so they're gonna get say $2 million each. If A charges low and B charges high, so the one that is A who is charging a lower price will get 6, and the higher the guy who is charging a higher price will get 1. So high 1, low 6. If they both charge high prices, they're both gonna get 3. So it makes sense for both of them to charge high, right? Because in that case they will be earning 3 and 3 each respectively. But the catch is that they really don't know what the other guy is gonna do. And that is the beauty of this game theory. So now again, we're gonna play this particular game and see what will be the Nash Equilibrium, or whether there will be some dominant strategies or not. Suppose firm A thinks that the firm B is gonna charge a lower prices. So firm A has to decide low or high. Low or high? I think low. Now suppose firm A thinks that firm B is going to charge a higher price. So firm A, low or high? Low or high? I guess low. So as you must have figured it out that in this particular game so far, firm A looks like having a dominant strategy of charging a lower price, because even if firm B is charging lower price, it is charging low. Firm B is charging higher price, it is again charging a lower price. Now reverse the game. Suppose the firm B now thinks that firm A is going to charge a low price. So firm B, low or high? I guess low. Now suppose firm B thinks that firm A is going to charge a higher price. So now firm B, low or high? Low. So in this case, firm B also has a dominant strategy of charging a lower price. My dear friends, when both the players are having a dominant strategy, there will have to be a unique Nash Equilibrium, which we found in the case of prisoner's dilemma as well. So guys, this is our Nash Equilibrium. Now guys, this game is quite an important one because it will teach us two different things, two new things. So please focus. Now suppose we have got a game where we have a batsman and a bowler. So let me call it as player 1, that is bowler, and batsman as player 2. Now so far we have done 4 questions. In all the questions, the strategies for both the players were same. In this case, I have deliberately changed that. So batsman have got 2 strategies. Either he'll be hitting a ball or defending it, hit or defend. And bowler also has got 2 strategies, but these type strategies are different. From bowler, the first strategy is bouncer, and the other strategy is Yorker. So this is one new thing which is different from the other games that we have played so far. There is one more different thing which we shall be exploring while we solve the question. Let's start. Guys, let's play this game. Now suppose bowler thinks that batsman is gonna hit him. So bouncer or Yorker? I think bouncer. Now suppose bowler thinks that batsman is going to defend. So what should bowler be doing? Bouncer or Yorker? Well, a bouncer. So in this case, bowler has a dominant strategy of having a bouncer ball. Now, reverse the game. Now suppose batsman think that the bowler is gonna bowl a bouncer. So batsman, hit or defend? I guess defend. Now you've got to be extra smart. Please have a great look. Now suppose batsman think that the bowler is gonna bowl a Yorker. So now don't you think batsman is gonna hit or defend? Hit or defend? Since they both are same, you have to underline both the points. So if there is a clash, you've got to underline both the points. Now in this case, guys, as you have seen, this is your Nash Equilibrium, bouncer and defend. So I hope the pure strategy examples have been great for you. If you want to practice more questions, you can WhatsApp me at my number and I should be happy to give you lots of questions to practice under pure strategy. In the next video, I shall be teaching you mixed strategies.